manager and I'm your product manager. And you can ask any question related to product to me, and I try my best to answer your question. And your role here is you will design a working model to solve a business problem.
Yes. Yes.
Yeah. Okay. Let's get started with the problem statement here. I'm not sure you have experience reading books online or on app. So say if you're on the Kindle, you read some books, then the system will try to recommend some new books for you. So for example, if I read the book Python programming language, it probably will give another book called using Python to process data or something. So this is all good. But we found the problem is the new books are highly related and overlapping with the previous books, especially for learning purpose. So say, for example, for the example I mentioned earlier, in the Python data processing book, they will probably also cover the basic Python programs, Python syntax, so which I don't need at all. And some of them, maybe they might need some in-depth knowledge. For example, it might cover something about feature engineering or something, so which I need to learn some machine learning backgrounds, like one-hot encoding or how to fill the missing data or something. So here is after we get the recommended book, we also give them a guidance about how to use the book. So say, hey, Denny, you already read this book. Awesome. You can read this Python data processing book. You can skip first 3 chapters. For chapter 4 or whatever the unit, you need to pay attention to something. This might be new to you. And for the chapter 10, maybe you need to reference another book for some background knowledge. Yeah, kind of like this. So this is the overall business goal for this feature. Any questions?
So I'm trying to clarify.
Yeah.
So I get recommendation after reading some books, and based on recommendation, I should get some guidance on how to use the book. So the goal is not to recommend a book, but based on existing already read book and also new recommendation books to give guidance to how to use the book. Is that the task?
Yeah, that's absolutely correct. So we can assume we have another service. You can call them or something. They can give you a list of books along with their metadata content. And as long as whatever you think is useful from the user set. So for example, I maybe already read some books. I maybe have some pre-filled profile, like I'm interested in programming or something. So whatever data you need, so you assume they already exist, and you can call some downstream service to get them.
Okay. So I'm still a little bit confused about this recommendation. So are we going to give the new recommendation? Are we going to give guidance to a person who already have some reading histories, or we are going to give guidance to a person with a reading history plus a new recommendation, a new recommended book? So is this newly recommended book a condition or not?
It's a condition. So
Okay.
technically, it's both side. So say if I'm reading some books, I got a recommendation for this use Python for data processing, I can get a guidance. And another person, for example, Sophie, also get a recommendation for these books, for this book, but she might get another different guidance. Maybe she never
Embedded.
used Python before, so she need to start from the first chapter, which I don't
Okay.
need to. Yeah.
Okay. So I assuming the guidance is in term of text plus actions, possible actions.
Mm. That sounds right. So that's in any format, I think it's fine. You use points or verbs or something, this is totally fine. And if you want some more understandable language, we can use LM or GenAI to write a paragraph or something. But here is just get the point. So we get what exactly the recommendation will give. And you can give them in keyword format or paragraph format. It's all good.
Okay. So the business goal, I just try to understand the business goal here. So the business goal is try to doing this kind of guidance to help, like first is increase user experience, user experience on the Kindle, and so that it will increase the, for example, like MAU or something like the user online time, reading time, whatever. And also, we are trying to increase sales of books if we recommend the right book, right? That also could be part of business goal. And this could increase revenue, both actually increase revenue finally. And if my understanding correct is these possible actions. So shall we set this action set a fixed list? I mean, because we can make it recommendation going very wild, but it's not going to be very helpful in the case of real scenarios, right? We want to make it, let's say, for example, let's say we can constrain it into a couple actions. Like for example, first could be, let's say, recommend a new book. So it could be potentially a prerequisite.
I think so. I think that's a good suggestion. So we don't want to get unlimited recommendations, right? For content, maybe because each book cover different content set, right? But the actions here, you can simplify that as you need to read the full section, and or you need to skip through that. It basically means you can skip them or spend less time, or you probably need more time and to cover some to get something from some other books. Yeah, let's say just start from these three. You can spend less time, same time as a reading book from beginning to end, or more time, need more reference. Yeah.
So basically, we go over section by section, and let's say what we can do is 3 actions. So it's increase or reduce time over a section. Is that sound right?
Yeah, sounds right. Yeah.
Okay, so it's basically.
And also, yeah, regarding your goal, so all the business metrics make sense to me. But here, let's picking one important for this feature. So basically, we are not trying to get users to spend more time on books. We are trying to do the reverse, actually. If they can spend less time, that's better. But we don't know. We don't know like how people read faster or slow, right? And maybe we can just take some actions like the user took your suggestion or not. So after they read your guidance, they say, okay, this is good. Let's go with this plan. Or they say, okay, I just want to read the book by myself.
So basically, user took the actions.
Yeah.
Or follow the actions, I would say.
Yeah. Or user accepted the actions, right?
Yeah, yes. So those are high-level business goals, but so let me think about it. So basically, we only need to, do we need to recommend other books? I don't think we need to recommend other books, right? Because this is like prerequisite of this book, something like that. Do we need to do that? Recommendation?
I think we do, but let's say it's out of the scope. So say if we do need to recommend other book, let's just say we can call the service, underlying service, say, hey, I have this user and I need some book about advanced machine learning algorithms. Give me some book. Yeah.
Yeah. So based on our conversation, our online metrics could be users, actually this I already put here, user certification, and then the rate, the percentage of user follows the actions, right?
That's right.
Yeah. So that is what we want. And the offline is basically, actually we also have another thing. So yeah, so basically offline it would be similar thing. It's basically we do we recommend the action, and then we use a proxy to say that if user follows, let's say if we just say this is a very, how do we measure the user reduce time, like the action of reduce time?
Let's forget about that. Let's just think the user take your suggestion or they want to ignore that. Let's just use these metrics. Yeah.
Okay, they just.
I think reduce time is a little bit tricky, right? Some people just read very fast, so it's not very reliable.
Exactly. So assume that on the UI, right, we have a button say that take this action. So that say you say okay, okay, then this will be good, right? So basically,
exactly. Yeah, you can assume.
If you acknowledge or reject, right? So something we have a UI like that. I mean, this is a bad thing, bad design, but let's just say for the sake of this conversation, let's just assume we have this kind of thing.
Yeah, that's good. Yeah, that's good. Yeah.
And we can use those as a measure labels, right? Those can potentially be used as labels and used for offline evaluations if we want to keep collecting those data.
Yeah, once you have some data, yes, you can use that as labels. Yeah.
I mean, this is for evaluation. If we have some evaluation like that, once we have some data, but if we didn't have any data, I think we need to collect, and also we can ask human to do some labels. If we have some golden set, we can also ask human to ask. But the label would be very difficult because every person is different for everything. So we probably will have some incentive program to ask some pilot users to read those and give labels. So basically, we just have those low-cost incentive users to do that. We give some money, or give them some free book to do that. But anyway, so that's just some potential metrics we can do offline and online. And yeah, so let's talk about the high-level design, since that's what you're doing most. Yeah, all right. So in a high level, I feel like this is a classification problem. So basically, we reduce the problem scope down to the classification. So at every chapter of the section of the book, we just say it is it should increase or reduce. We didn't have any other things, right? So if the increase or reduce is classified correctly, user will get some feedback. Incorrectly, user will also get some feedback. So that could be a classification problem.
Sounds good.
And then it will take some input of that, right? So the input of that would be the current book sections. Second is the user previous read book and their behaviors. And third, if we're allowed to use other users, I don't know if it's allowed.
Yeah, I think as a system, you can, as long as you're not exposing directly, but let's assume we can.
Privacy. This is a privacy problem issue we need to approve. But anyway, so if we're allowed, we can use other similar users reading time, and yeah, so our reading behavior on the book, and the output is increase, decrease, nothing. It's just like normal. So three options, right? So
sounds good. Yeah.
Yeah, and so I think I'm going to collect some features and train a classifier for that. The biggest problem is how to correct the initial data about this should be increase or decrease. So maybe we can initially using some incentive or use some rule-based approach, maybe rule-based approach for code start. the potential rule could be if this section is very similar to previous book you have already read, it's very similar to your previous reading experience. Like it could be skip. Actually, you know what? If we can find a similar book you already read before, then we can use that as a signal to guide this book. So, for example, in the previous book, you have a similar section that you jumped a lot, right? So probably you can use that signal to indicating I should jump this as well. The same thing.
Yeah, that's an interesting idea, but it's kind of conflicting with this feature, right? So the whole point of that is I already read a book, so I want to skip the whatever I already learned from that book, right? So if I spend a lot of time on like I don't know what I said, like OO design from my previous book, that means I already have good knowledge of that. So that for the new book, I want to skip that instead of spending more time on that.
Oh yeah, that's what I was talking about. So we use as the
sorry, I misunderstood. Yeah,
use that as a heuristic to determine if I want to skip this or not. So so yeah, this is about this previous read book as the input, right? We need to extract the previous book's behavior and also content. So the rule initially could be that if the content in the previous book is very similar to this content, then I should get skip. So otherwise, it can be false. And also the behavior, right? If previous content that user they skipped in previous book because they don't like it, probably we can skip the similar things here. So it's because it's become learning from previous behaviors. And the idea of learning from other similar users is I just try to find a user with a similar reading history that actually read the same book and to see that whether he decided to skip or increase or use normal speed to read this particular book.
Yeah, that sounds reasonable. Yeah.
Yeah, those are two signals from either from himself or from other users. Yeah, and the privacy issues need to collect from users. Let me think about any other way. So let's starting with those. Let's try to think about it later. Yeah, we can try to solve code start problem a little bit later, but just for the sake of some time, let's just continue. So data collection. We need to collect some data. As I said, we need to collect the all read histories of users, including book, section, and the time spent, and the action response to actions, to suggestions. If they already have this feature enabled, responses to the suggestions. And yeah, histories of users. And we also need to get preprocessed books. Right. So basically, for section, we just see if we need to extract content of sections. That's important. And also we need to collect some kind of user profile. So every user have their profile, like age or their knowledge, their domain, whatever thing we can use. And the user profile may be on Amazon or other. Maybe on Amazon account. So basically, his either previous purchase something, we can create a user embedding. So we are going to use this to create user embedding. Actually, user embedding. Sorry. Then I will use all the data together to create user embedding. But I just say those are the data I'm going to collect. And so talking about features, right? So I'm going to modeling the features. So from the user, every user of this, basically the reader, I'm going to create their basic profile, embedding, and their reading history, embedding it, and their we need to their book reading history embedding is including actually including two things. One is the embeddings for the entire history to join. So one is the entire history to create one embedding. And the second is about the embedding for whatever keyword like features, embedding of features, text features.
Yeah.
For the
here, so say if I have a list of books reading history and each of them with all the actions you need, whatever the content or actions you need. So how do you do the embedding?
Yeah.
So what kind of model or something technique you use to build embedding for each of the book?
Right. So I have this two purpose differently. So the second embedding I created for each section is I'm trying to find out similar section and similar books that this user already read. So that is the purpose. But the first one is try to create to create a profile for the users. It will be joined together with the user profile embeddings user on Amazon. For example. So this first embedding is going to predict the user's behavior, like how similar this, what's the next potential behavior could potentially be. So that say, the first embedding will be joined together with his actions, actually. This will be joined with actions. So based on your question, right? I assuming that you asked me that I given a history of all the embeddings, the books is read and the behaviors of jump or not jump. So what I'm going to do, right? So I'm going to create this embedding from history by doing recursive networks or whatever transformer, causal transformers to do that. So
okay, sounds good.
Yeah. So basically, I'm going to have each action will have its action embeddings, and each book section I read, it will have its content embeddings. By pre-trained the model can generate that, and then I can just go into I mean it can be modeled as a causal sequence, like you know, any GPT-like model could be working in that way. But
sounds good. I'm trying to understand like each embedding, each like if there's a vector output, each of them, so what they are representing. So I think you get it. You answered the question. Please go on.
Yes. And and then we want to collect users like network features. So basically, we want to find out similar users and similar users that who has read the current book, right? And their behavior. So basically, we want to get say their reading time behavior comparing to the average time on this book. So basically, for those special users, similar users, what's their behavior compared to the overall average of this particular book, and also their actions. So if they already begin to accept this new feature, they also would have actions to skip or not, right? So I'm going to collecting those as well. But one thing you to be attention here is this is dangerous because this is what can potentially cause feedbacks. So if I recommend to skip and people let's say they just skip, and I mean this skip could be biased because I asked to skip and then just blindly accept it, because not many users, they will carefully read about this content before they accept action. They just blindly follow the actions. So if we do that, then the content that it would be potentially biased by what we recommendation going to be, or our previous classification would be. And if we use that as a feature, it can potentially reinforce the behavior. And
that's right. Yeah, that's a valid concern, and it's a real problem, right? But for now, let's just say we can, like, the model just run independently, then it's not taking the feedback loop. As for now, maybe we can address that later on.
We need to pay attention to that, right?
Yeah, that's correct.
Attention to
that's a very valid concern. Yeah.
Okay, so this network features, and then we potentially also have content features. The content features is all the books. Maybe their author, their category. Actually, the history should also including the head category, the book category, or whatever. I think that you get my point. The user feature, the reading history should also including all the author category and the sections and the embeddings, section embeddings. But I'm not going to enumerate all the features, but you get the idea of those most.
Sounds good. Yeah, all the metadata, right? Yeah.
Yeah, and what else going to have? So the overall popularity is not going to matter because we just about actions. So what others will decide our action. So based on I will decide, I will just temporarily go with this. I will find out what's going to do after that. Okay. So once we collect those features, and as you can see, many of the features, they are not just raw features. They are features needed to go through some pre-trained models or like embedding models to get embeddings. It's because it's starting with embeddings, right?
Yeah.
So because of those embeddings, this will make my final model has a couple options. Because my model is highly embedding biased, so everything, a classifier with deep neural network, maybe it's too dense. Let me think about it. So initially we will have a baseline model. So baseline could be just use heuristic based, rule based, just find using embedding similarity for code start. So basically, initially we have no data, so we're just saying that, okay, given that this section is so similar to previous section, well, let's just try to skip that. And this is some kind of rule-based things, and we are going to collect users' feedback based on that. And we are going to evolve those models to be trained simple neural models, neural classifier models, right? That to determine if this is going to be right or not based on feedback or feedback based. And the input of this model, it would be all those embeddings. It's a joint embedding features, and there are some categorized features. Actually, let me think about it. Yeah, so this just need to be a simple classifier. So we just need to feed in all the personalized features into it, all the personalized like profile embeddings and the reading history, joint embeddings, and also the current books embeddings, the section embedding, and also we need to also have some discrete, have some categorized features. For example, like actually Tableau feature. Tab features. So tab features means that those features we engineered. For example, let me give some like some example. It would be if similar user has skipped and it should not be binary. Actually, it should be %. Similarly, it has flipped or has slower down, something like that. And is this section like what's the percentile of similarity with the history, like when, like with the reading history, something like that. But I think most of them can be inferred by embedding as well. I'm just trying to think about if any other obvious were missing, but we are going to add those tabular features. They are going to be numeric ones, and the numeric ones to feed into neural network, actually we can normalize those features. Just need to normalize them into percentile or whatever, and then put them into joint, sending to a neural network. And neural network can be just a pretty thin initially, and then just couple, maybe 5 layers, and with some skip layers, and then or even if you want to use transformers, that's all fine. And then create a classifier. If you use transformers, it will be a prediction head. We can use BERT-like. Wait, let me think about it. Yeah, I think using BERT-like thing is also fine. Just use a prediction head in the first token. Try to output the putting all the information is needed and to generate the final answer. And this approach would be we need some training, so it potentially can be heavy. Initially, we don't have labels. That could be problems. That's why we have a baseline. But alternatively, if we want to make it easy to avoid overfitting initially without too much labels, a linear models could also used. But one thing we need to pay attention is when we use linear models, we can't directly feed those embeddings. We have to cross the embeddings. So we have to pre-cross embeddings to generate some kind of like the similarities to send those numbers into a linear model or even a tree model, whatever. Yeah, that should work. Yeah, so does that would be my first thought about the design, and hopefully this answers most of the questions. And
yeah, I think so. I think this end-to-end working model. Yeah.
Yeah. So, and now I'm going to just think about the next step. It will be offline evaluate. Offline evaluate is when I collect the data, right? So before the user, I mean, we can, as I mentioned earlier, we can have some incentive users to ask them to use this feature, and then collect some golden set. And then I will use this golden set as a label set, divide them half, and then try to not half, I mean like 80%, 20%, and use 20% as validation offline, test offline, and then try to test how well it generates, and also create offline prediction accuracy, precision, recall of the because this is a multi-class classification, so we need to, sorry, I didn't clarify this very good. So when the model at the end, we will use cross entropy, right? We solve the max of multi-class predictions. This is one way, but another way could be we can use we just simply use 2 classes. So the 2 classes is just, let's say that positive or negative, right?
Yeah.
Negative. So basically, if so we have a confidence room in the middle. Let's say if it's, let's say, less than 20 over 50% confidence, we just do nothing, but otherwise we just do the recommendation. So I will say just using the 2 classes is better. It's simpler. So I just use 2 classes, positive and negative, and this will be the same thing. So the measurement is, we need a calibration. If we use 2 classes, we need to calibrate the boundary for 3 classes. So this one can be easily done by the validation data set, so that we can separate the positive and negative from the neutral set. And yeah, so, and after that, we can do the offline prediction, accuracy, and precision recalls on those actions over actions, multi-class prediction recalls over. Yeah. And maybe also F1. I don't know, whatever you can think about offline. And then if it looks good, we want to try to do a A/B test, not A/B test, like A test, whatever, to see if the infrastructure is fine and the testing infrastructure is okay, then maybe starting with a small user, maybe 5% A/B test. And the A/B test is trying to see that if the overall satisfaction rate and also the reading time get reduced, as that was our one of the goal we mentioned earlier, and also testing against the user follows action rate. It's because this one cannot be A/B tested because starting from empty, right? We don't have the user previous behavior, so we can just simply use A/B test to measure the we can just use the and let me think. We can just try to set a goal on the one side and then try to see that if we achieve the goal by using online flight. So that should be fine.
Yeah.
And if
let's say the product management team somehow helped you to get some true data for you. Like they either pay some users to ask them, give some feedback or something. They give you some metrics to say, I like it or don't like it. Or I want to take it or don't want to take it. Then let's go start with here. Let's say we can collect some metrics. Then what should we do next?
So is this a real, I mean, so if they can collect some data, right, it will be offline data. I got that. And I will do offline validations, offline precision recall, F1, all those things, and do offline tuning, alignment, calibration, all the things I use that. But this one I'm talking about is real flighting. So basically, if offline works all fine, we begin to do a real flighting on users. That's a different story. So this is like pre-deployment, like we almost try to flight the model.
If you flight the model for 5%, how do you decide you go more or you want to stop?
Yeah, that's exactly what I'm trying to say. So we want to define guardrails, right?
Okay.
And the product metrics. So basics, we want to first, of course, measure all the product metrics to say that, the overall product metrics is going to be, there are 2 things, right? One is overall user reading time or user reading books, the Kindle time. So if our goal is to reduce their time to spend after reading, it should be reduced on that, but the active users should not be reduced. And the user feature, like the feature abandon rate, like whether the feature, if the feature has a turn off button, right? If the user pick that button, click the button, I mean, they shouldn't do that. And the guardrails, including features like measures like if this feature affect, for example, if we increase this feature, right, and the user should not reduce spending money to purchase books. I mean, we want to, because this can potentially make user stop purchasing books. This is bad. We want to make sure that our revenue is not impacted, and we want to make sure that users they don't switch to different reading devices. So, and all those guardrails need to be installed there to prevent bad thing happens, right?
Sounds good. Yeah.
Yeah. And what's next? Yeah, then if all things good, we are going to scale up. Green light, we're going to scale up to maybe 50%, 50%, and then we are going to compare their behaviors. Hopefully we can compare against the baseline, because I talking about the baselines previously, right? So so the baseline here, we will fly to the baseline first, and then if the baseline passed the past all the things, we are going to say that we're going to slowly compare the baseline, compare our new model against baseline. So this is like multiple iterations. We were starting with baseline. If we have no data, we use a heuristic. And then slowly, if we collect more data, we're going to switch to train the models. Maybe starting with a linear model, easy to train, and then slowly switch to a neural model, gets better fit. But this all become a continuous iterative progress. But I'm talking about is here is like every model before this release, we're also going to go through this process. And if we don't have previous model running, we will compare against the preset goal. And if we do have model running, we will compare to the previous model to make sure that those metrics, they get improvements. And at all the time, we're going to measure and monitor all the guardrails not to fail. And if that goes well, we will just scale up a new model. Yeah. And yeah, there are a lot of things we need to think about in the A/B testing. For example, like A/B testing easily get misled because we promote something, and also it can potentially get misled by I don't know. Sometimes user may, as I mentioned earlier, they become brainless, and then it's not directly reflect the quality. The compliance rate increase, it may potentially because user trust us, but in all sudden it could be all bad. So we want to make sure that those things not happening. So maybe
how do you make sure those things are happening? I mean, if you say some users are giving some bad data or something, then we are while it's running, we're also collecting data for the future training or improvement, right? So how do we know when should we take the data to retrain, and when should we reject data and see some reduce of the metrics?
Yeah, I think that is very, very good question. So I would say we should have a different model to try to monitor the user behaviors and try to predict the consistencies from different angles. For example, right? So if user ends up compliance, but somehow at the end, let's say he have behaviors, let's say frequently come back to the skipped at the part, but for example, when he read this, take more time to read, like carefully read, but actually he in the middle he just say, oh, this is something I'm not like at all. So I end up to drop in the middle. So those like inconsistent signals indicating that the quality could be, compromised. So we need to pay attention to those to have a monitor on that.
Yeah, sounds good.
Yeah. So basically, this is like data monitoring, the DQ monitoring. This is very important. And this data quality monitoring should be running on the pipelines all the time. But initially, we wouldn't have time for that for sure. I understand, but and sooner or later we want to add that, and also the model's flexibility, right? So basically, if the model was trained, how often should we, let's say, retrain it? Like should we even consider personalize the model completely to each user? Well, based on current design, I don't think full model personalization is needed because we have a feature personalization. However, we do need to think about if you want to accept online, do some online real-time reaction. So basically, if user's behavior, let's say current behavior, when he previously accept or reject a lot for this current book readings? Should we do some real-time predictions to do something like at the very minimal? We should say that we should drop the feature, right? Turn off the feature if user reject a lot, because we don't want bothering. We figured out in real time to say that the user is not happy with it. We should turn off. But more smartly, we can utilize that behavior to adapt the model based on the user's real-time feedback. But that is a different story. We are talking about real-time model signals and adaptations. It will take more time to design, but I don't want to cover it in this. But I just try to mention there's possibility if we want to drill down in that direction.
Sounds good.
And lastly, scale up.
Yeah, go ahead.
The model, of deployment. We should just think about like this neural models, like all the features should be prepared offline. And some features are offline features, can prepare offline, but some features are near real-time features. We should do a near real-time streaming pipeline, like Spark, to collecting those and then put them into a feature store and cache those features, because all the embedding computation can be cached, right? Because those embeddings, they don't need to be recomputed again. So we just use a feature generator to cache them in feature stores. And all those cache can be distributed into feature store cached, and then model can be run in scale as well, because we can just load balancer them into different model servers, and the model server depends on whether they use GPU or not. Most of models is simple enough, they don't need GPU, the CPU is good enough. But for neural models, if it's complicated enough, right now I don't see why it needed. But I only think that those encoding models initially, the embedding generation models, by text embedding generation models, they potentially use GPUs, but the final ranking models or classifier models only need to be CPU is enough. So I don't think GPU is needed. So it's just CPU machines get load balancer and the fully stateless, and all stateful things are the features. They are all in the feature stores, and those can connect with near real-time or even real-time feature store pipelines and all well cached. So I think that should be no problem with scale up.
Yeah,
I think
that sounds good. Yeah. Anything else you want to mention? Talk about your end-to-end design.
Let me think about. So feedback, users, engineering, monitoring, scale up, deployment. And actually I'm just trying to checking up with you about the let me think about data collection. I cover that, and the business goal. Yeah, I think I covered most part of the important pieces. I might miss something, so I need your quick hint if something obvious was missing this design process, or probably it's different design culture here. So
yeah, I think you covered everything. So it's end-to-end covered, included all the machine learning life cycle. I think you covered most things.
Yeah, the training things. I didn't talking about the model formulas and the training details. Do you want me to talk about that? So yeah, I mean, I can talk about that, but it's just I don't think enough time was left.
I think you can talk about that. We can spend a little bit more time here.
Yeah, so I think the thing is, I mean, which particular areas you want to learn more about the training? I can dive deeper.
I think this is up to you. So which area do you want to dive deep and talk about?
Let me think about it. So multi-class classification. So I think we skipped about biased data training, right? Let me think about it. How can we overcome potential bias in the training? So the potential bias we can get is user just blindly follow our actions and get the labels, and the label collected. Let me think about it. So once we get the label collected, we want to clean up the labels, of course, if user clean up labels means that if user compliant but they regret, and they should just regret means that they accept this behavior but their later behavior skipped it or even they change their behavior, then it should be remove those labels. And in the training, yeah, I mean, we just if we train neural networks, it's just a general simple PyTorch model. It should be fine, but we just need to do some parameter tuning if we want it to maximize the performance. So we can potentially add some regulators to make sure that yeah, I mean to make sure the sparsity do not overfit into this training, and the regularizers could be many things like in the model we can think about. I mean, let's just think about modeling, right? So the modeling could have layer normalizations. We can try to have skip. I mean, has drop off and all those things we can think about. And if let's say yeah, I think the transform models, pre-trained transform models. Oh yeah, so the training process could be think about let me think about one more thing. I think we need to train that embedding generations together with those final models if needed. So the embedding generations, including how do we
So you
generate
mean
the encoders?
it's not a different model to generate embeddings. Now you want to make them the single model, right? Oh,
It's a different model, but it need to be joined trained. But how?
okay.
Yeah. Otherwise, I mean, it can potentially. I mean, so for example, right, the RNN model, or I should say, user behavior encoding model, how that can be potentially trained, right? So that need to be trained, and we should to use. We can potentially use, for example, contrastive learning, right? To if we ever have some labels, say that two users similar in behaviors, in reading behaviors, we should try to make their embeddings similar. Otherwise, we randomly pick something, make them embedding unsimilar. So contrastive learning can be applied when initially pre-train these encoders of user behavior histories. But once that's finished, we also need to join the training those embeddings together with the final prediction model so that make it better. And also the final classifier to make it more generalizable, it's can have make it multitasked. For example, we not only predict if they want to do skip or keep reading, we can add more prediction heads to make it multitask. For example, we can try to predict, let's say, other behaviors. Let's say if they want to, let's say we can try to predict not only the sections, like basically the pages, how likely they're going to swipe the page out. Maybe we rather try to predict, let's say, if they are going to leave a comment on the page, or I mean, all other behaviors. So those going to help to create, if we get more signals from those training head, right? So we're going to help regularize the internal representation of this user, and it can help with the final prediction accuracy of the current classifier as well. Yeah, I think that is pretty much what I'm going to talk about on the
Sounds
model.
good.
Yeah.
Yeah. Thank you so much. I think that's the end of our mock then. Yeah.
Yeah. Yeah, it's had, yeah. Oh,
Let's see. Yeah. I think you covered everything from interviews points of view. And one thing I'm not very clear is, we can switch to Chinese, right?
好。
对。然后就是说有一个我不是很清楚的点，就是说你这个 embedding 有一个观众在这边也提到过，就是说这个 embedding 你是怎么生成的？然后 user 这边我知道的，就是说content 那边你是就是说是用。
要有那么多，有非常非常多的那个 pre-trained 的 embedding models，比如说 instructor 这种东西，现在有特别多。
我知道，但是你的就是 input 是什么呢？就是一个一个的 chapter，你就把它全部作为一个 input 嘛，就是一个一个 input 的 entity，然后去给他们每个人生成一个 embedding 吗？
像那个 section 的话，我们有很多方法可以做，对吧？就是说，
啊、
像一个如果说有两种 embedding 的方法，一种 sparse embedding，一种 dense embedding。如果 sparse embedding 是比较简单的，就是你用那个 token，类似于像生成一个 TF-IDF 这样的东西，你压根就不用 train，你就直接可以通过这种方法来生成一个sparse embedding。但是如果说你想有一个 dense embedding 的话，是这样子的，我们可以用那个 existing 的那个pre-trained 的 model，但是 pre-trained model 它有个 limitation，就是说它那个 input length 它可能只能生成256不是512个token 吧，这是比较短一点的。所以这个时候我们有两个方法可以去做。第一个方法就是我用那个就简单的通过一个比如说 prefix，就是我找到这一段的随机采样几段，然后每一段就是也不是随机反正就是说我自己我用这个apply 它，就是我选出几段，然后分别 apply 它的那个 embedding method，然后再把这些 embedding 给综合起来，给加起来。还有一种方法就是我用一个 GPT 这些 model 去做一个 quick summarize，然后把那个 summarize 的结果再去做一个 embedding，就是这两种方法都是可以用的。
对，这个你可以就是可能也可以稍微提一下，因为但是我没有往这个方面上走，因为就是这个 embedding 可能会有，现在就是你各种模型的话，你大概也可以这么就是做这种，我不知道你是刚才说那种 sparse 的那种 encoding 是，嗯。现在就是对这种场景下面 work 有多好，因为它在就是说它设计的各种各样的题材的内容和什么的话呢，就是说，我不是很确定这种方法会不会很有效。当然你这个可能比我更专业一点，就是说你可能觉得它也是 work 的。当然这个 token embedding 的话呢，就是说这个里面就是说它会有各种各样的长度的题材的各种各样的文章。各种各样的书，对吧？所以就是说，你可能会做
对对对
一些预处理，可能会好一点。
对对对
因
对对，
为对，然后还有一点就是说，就是说你这个如果这个和这个经验的这个，比如说你是根据他读过的一些书的东西来推荐他后面的东西，对吧？那么他读见的这个东西的，不同的主题、不同的题材，会不会让你的模型的效率会下降？这个我倒也不是很清楚，可能你更清楚这一点。对，我的例子就是说，比如说我是一个只读技术书的人，对吧？那我
嗯
读了这种 Python 的 programming language，我读了 Python 的那个 pandas，这就是 data processing，然后现在我要去
嗯
读这个 machine learning 的feature engineering。然后我是
嗯
另外一个人呢，就是说他也读过这两本书，但是同时他还读了很多的历史书，
嗯
什么的明朝那些事儿啊，又是什么大唐、什么清朝康熙啊，这些读了很多很多的这种东西。那么这两
嗯
本书只是它的里面的可能1/10或者是多少。那么这种 embedding 的话，我刚才你在说的时候，我就在想，就是说你如果是把它做 embedding 的话，把把历史上这些东西做个 embedding，我不确定你就是说做完了每个 chapter 做完 embedding 之后，你还要把它总结一下做个 embedding 吗？还是说你从中间取出来一些作为你的 feature 的 input？所以这块我不是特别清楚。
对，就是有两个 feature，我还是要就是完善一下。就是你刚才指的这个东西，呃，是指的就是说，嗯，我
我的意思就是说，
对
我有两个 input，像两个 object，对吧？一个 object 包括另外一个 object，但是也有很多的噪声 noise，就是这个 embedding 是应该是能知道它这个两个东西有相似性的，对吧？但是
对
我
对对对
不知道它的相似性会不会被那个很多的噪声去冲淡。
对对对，你说这个
嗯
点提的非常好。就是我其实设计的时候有一个失误的地方，就是没有去把那个就是数据量考虑进来。因为我的印象中大概就是你之前读了呃一些书，然后就这些书就是取了一个综合。当然了，我也会去，就是我这个软壳里面没有去特别展开讲，就是它如何去 take 另外一个 feature。因为我刚刚说这个 embedding 有两个 embedding，一个是user previous book，这个就是怎么说呢？就是一个就是它的那个整个一个 embedding，entire history 是一个 embedding，还有一个就是说它的 history 里面每一本书都是分开的 embedding。那 第一个 feature 可以直接 embed 进去，对，我提到了。第二个 feature 的话，它是不能直接被 embed 进去的。第二个 feature 要进行一个 lookup 的，就是说你要去先把它放到你的 history 的一个 vector store 里面去，然后再去把你相似的书给找出来，然后再把它放到那个里面去。也就是说，你要
你
先去做个
先做了一个
retrieval，
similarity 一样的东西在中间
对，你要先做个 retrieval，
那 make sense
对，这个
对
但第一个是直接放进去的，它是作为你整个 profile，就是我
对，
是
这个是可以的，
没有展开
对。
讲这个，不好意思，我是的确漏掉了刚才那个在讲的时候。
那你这样就 make sense，这样就是
对，
说整个的过程是完全是正确的。然后，反正就是这个，那么我们也稍微说两下，就是从面试的角度讲，对吧？我也做了一个问卷，所有的观众我们也可以就是说给我和这个同学我们一块儿做一些个评价。然后呢，我这是跟那个另外一个组织的一个林老师学来的，当然他做的比我好很多，我就做了一个非常简单的这么一个问卷，大家看一看，就是我们两个人的表现，在各个方面都有什么好的地方和不好的地方，你也可以有一些这个feedback。当然，我从这个interviewer 的角度来讲，我是从这个 ME 的角度来讲，我觉得这个是完全是一个非常好的面试，各个方面都还是可以的。然后沟通也好，需求也好，然后模型的按图案了也好，就是都还是不错的。然后，你自己也可能也觉得，就是模型这一块你没有往深了挖，这个可能就是你这个走向的问题，就是你把它做成一个 classifier，然后呢，embedding 是用一个模型来做。可能你也没有什么太多的东西好往深了挖了。我事先想的是有一点儿这个里面会有一点儿这种，有点 sequence to sequence 的这种感觉，或者是有一点儿这种，呃。或者有点是这种 knowledge graph 一样的味道在里面，所以我是觉得这个模型上面还是有些东西可以说的。但是你把它就是做成这种 classifier，这个也是 work 的，就是从面试角度来讲，这个复杂度足够了，不可能做成一个真正的可以 production 的这种模型，这是不可能的。这种模型应该是，想的我觉得还是各个方面还是不错的。当然，等会儿我们也看看现场的，观众们给我们两个人的评价是怎么样的，然后呢，就是说这个题目呢，刚才有同学也在问这是哪里的题目嘛？我是自己找了这么一个题目，然后这也不是说在哪个公司的题目，这个是我以前曾经想过要做的一个小项目。后来呢，想想呢，就是这个东西呢，可能没有那么多特别的技术性或者什么性的壁垒，没有那么多太多的专业性，所以我觉得可以拿过来做面试用，或者做各种各样的这种考题可以用。然后下面的话呢，就是说你想有些什么地方可以发挥的也好，或者是现场同学有些什么东西，可以用的也好，就是关于这个题目，如果是你来做的话，你怎么考虑这个题目？你会从哪些方面上讲？你觉得哪些东西你还需要再多的考虑？所以我想，我们能不能把这个东西做成一个像一个小的技术讨论一样？嗯。或者大家有什么就是关于这个项目的背景和这个需求方面的东西，也可以问我。我想想看，我们要不要给几分钟的时间，叫大家把这个问卷填一下？
对，就大家在填问卷的时候，我可以顺便就是再重新思考一下刚才丹尼老师提到的那个，通过 graph 或者是 sequence to sequence 的 model 来解决这个问题。就是 sequence to sequence model 的话，我觉得肯定是一个更加 generalized 的 version of what I'm doing，因为我们如果最终目标不仅是这么一个 action，或者说，嗯。其实 sequence to sequence 它也是一个非常常见的方法去predict，就是做一个 prediction，做 classify 或者是都可以。但当你的 prediction 变得更复杂，不是一个简单的 action 的时候，它可能会更加的通用化一点。这是肯定是可能更好一些的。但是就是如果说我们把这个问题简化到只是一个 binary classify 的话，那可能就没有就是太必要去麻这个烦，但是依然是我觉得是可能更好的一个 long term 的一个 goal。然
嗯
后那个 graph 的话， 其实是这样子的，我也觉得这 graph 是一个很好的一个想法，尤其是像这种 book 这种非常具有就是相似性，就是说有structured data 的东西。然后我个人想法是这样子的，就是像我们有很多 feature 可以直接从 graph 得到，就比如说刚刚说相似性的时候，有很多书本的相似性，不一定要通过 similarity，不一定要通过 embedding 得到。我可以得到一些 feature，就是这两个书是否相似，对吧？那你可以通过 graph 就可以得到它。比如说，我可以得到这本书相似的书，它的在它 first level neighbors，或者是它的那个second level level neighbors，就是说我们可以通过就是像 graph，就像 person 跟人跟书的那个 graph 做那个basically 就是做 collaborative filtering，对吧？这个东西也能产生一些 embedding，就是可以找到相似性。但是你也可以通过 graph 的graph neural network 这些的东西，通过 graph 的 connection 上去挖到更多的 signal，去找到它的相似性。它的 ultimately 就是你要去找到这个书的章节是不是可能跟它有相似的关系，或者是某种关系。当你这种 graph 的 edge 可以有不同的edge type，那有些 edge type 可以帮助你更进一步的去 nail down 你的 action。就因为但是这个 graph 建模的话还是比较复杂的，所以实际在使用当中的话，我们就会发比较靠后一些，就是最开始的时候肯定会用一些比较简单粗暴的东西来做，然后做完之后发现哎还有更多进步空间可以挖，然后我们就可以再挖一下 graph。但是像这种书本这种一些简单的 feature，我们还可以先直接从 graph 上找出来，可以先这样。这个就是我开始的一些想法。
对，这是对的，这个是正对的想法。刚才有个同学问我是我的那个标准答案，我没有标准答案，这是一个完全开放的讨论。所以我出这个题目的目的就是你可以往各个方向上走都可以，你往 graph 方面走也可以，你往这个 sequence to sequence 也走也可以，你做一个 classifier 也可以。这个我倒是没有想到 classifier 这个角度。然后你也可以用大模型做也可以，你就反正你用大模型给它做一些这个各种各样的prompt，用一些东西把它串起来，或者是你也可以做一个topic modeling，就是你原来
是的，
的书做了哪些 topic，然后你的新的这个书有哪些 topic，如果是同样的 topic，你还可以再做一些它这个 topic 和这个深度的一些模型，对吧？如果它是同样级别的同样的
对对对
topic，你就可以忽略掉，就可以这样的一
对
个东西。
对对对
嗯，
对，这个就是那个 summarization，就是说你刚才问我的说每一个 section 的 similarity 怎么比较，你说把它那个 section 的 topic 挖出来去做一个 topic modeling，其实 topic modeling 跟我刚刚说的那个
summarization 这样，
对，跟那个 sparse embedding 是很像的。你要建立 sparse embedding，其实很多时候你是建立一个 topic model。比如说你用了一个 BM25的
嗯
encode 这个东西，会产生一个 sparse 的一个 embedding，对吧？这个 embedding 它其实就是一个 topic model。然后或者说你用 LDA model，但这种一般不太用 LDA model，因为，唉，就是这是一种非常学术，但是在工业界很少用的方法，就是一般来说就是它的那个就是计算复杂度啊，各种东西就是都不是很 friendly，所以一般工业界比较少用一些。
嗯，对，嗯。对，不知道为什么你在说 TF-IDF 和这个时候，我一个感觉就是说，它给了我反正以前用到的这种都是属于效果不是特别好，就是说它的结果就是产生了一堆相似性很什么的这种结果，当然可能和我的 dataset 有关系，所以我第一感觉就是我会用一个large model 去产生一些 topic，然后我就去找它相似性。当然我在
对对，
最初的想的时候，可能在 large model 的时候也想过一些，你调一些参数，就是把它这个 temperature 调低一点或者什么样，叫它出来的结果尽量的更集中一点，
是的，是的。
都是必要的。嗯
你说的没错，就是垃圾 model 肯定效果更好一点，尤其是你可以去生成或者 summarization，其实这个都是一样的。但是就是我刚才说的那个东西，就是说在垃圾 model 如果你觉得它 cost 太高，那再或者说就是说垃圾 model 没法大规模应用，因为想想看，你要垃圾 model 去 apply 到 every reading books，这个还是有一定的 cost。every section，那也许这个东西是可以接受的，它的 latency 也是可以接受，那这个东西没有任何问题。就是而且 large model 的话，到最后你有
嗯，
topic 生成之后，可能还需要把它
对。
转化成一个 vector。 因为你会做一个 retrieval 嘛，因为我刚刚提到了，就是说你 section 出来之后，你不可能把所有的书历史就放在，所以你还得把它放在一个 database 里面去做一个 vectdb 的一个 retrieval，就是在这里，所以
嗯。
对
对，我可能更多的是给这种 MLE 做这种题目，可能是开始讲的更多一点。对，他就是说他做了一些这个可能要有一些 pre-processing 的过程，然
对对对对，
后
是的，是的，
现场去做的话呢，就是说你去根据这个书，你可以把它 retrieve 出来，你可以说 vector DB 也可以，你直接存这个 result 也可以，反正这样
对对对
都
对对对
是可以做的。嗯，
对对对对，你
但是
说的
你直接去现场去做的话，你的 latency 也好，什么也好，各种各样的考虑的话，可能会有一些 downside。嗯。
对，
好的，我收到了5个回复，回复还是很不错的，给你的评价都是非常高的，还是属于还是很认可这个你的这个答案的，还是很认可你的这个什么的，那行，
谢谢大家，
那我们就是这个样子，然后事先我也稍微写了一个